This is Spark Systems AFM in MSCF. This is a controller which needs to be switched on before we switch on the software, and this is what controls the AFM system. This is a vibration isolation unit which is under the table of the computer, and this is a power button, and this is the enabling button. This is how we enable it. Coming to the main system of AFM, what we see here is the scanner head plus the optical lens and other quite few knobs which will be used to align laser and PSPD, which we will be showing you shortly. This is what we call a chip carrier or a tip holder. These cantilevers, or we generally call them AFM probes. This way. This is a sharp tweezer which we would clean before using IPA. So we pick the tip, and then in the chip carrier we have this clamp area with this tip loaded. Next we will unload the scanner head from the system and keep it on this stand. So even before unloading the scanner head from the system, make sure this stand is on the table. This is a scanner head which we will unload to the right by doing this. So there are these two clamps which are in fixed area now, which tightens this scanner head into its position. So to loosen it, first we do this, press it towards us. Then this scanner head can be slid towards the right, like this. Turn it, hold it like this. So while holding it all the way, it needs to be taken care that this whole part shouldn't be touched. There's a mirror here which needs to be kept clean. Then this is taken to the stand on the table, and with the good support from both the hands, it's kept very smoothly on the stand. Scanner head is on the table now. We need to load this chip carrier, which is already loaded with the tip, onto the scanner head. So this part on the scanner head, this is a magnet, which is pretty strong, and the chip carrier is magnetic. So when we take this over here, it will stick onto that. With a firm grip like this, these two holes need to be aligned with these two ruby balls. As you can see, there are two spheres. Like this. Next, the whole setup, the scanner head, is picked up with the right hand like this and rotated it such that this goes into the system this way. Left hand gives this very firm grip now, and then as you can see, there is a slot here. This will be slid towards the left, and make sure that it is press fixed, and then tighten it into its position. This is a vacuum pump which is behind our AFM system. We can switch it on. This vacuum pump is for holding the sample into the sample stage. This is a controller unit, as I told you initially. So before we start the software of the system, that is NX20, Smart Scan, we switch on the controller. Then the vibration isolation unit, we switch on the power and enable it. So Smart Scan New, as you can see on the desktop, please double click. Tip is already loaded on the system, and as we start the software freshly, we can see this window. We allow it to do the initialization. When we say initialization, it automatically moves the stage in XY and also the Z stage, that is the scan ahead. After the initialization, this window will appear in front of you, which right away you can go and cancel and then close. And as you can also see, there is this line scan which can be stopped. So throughout the experiment, whenever this line scan is unnecessarily running, this one, you can stop the line scan. So we are in the window now. So you can see this optical window. This is the cantilever that we have loaded, and you have this settings of light and exposure. As you can see, this is the bigger part of the cantilever, which we can call the base or the chip, to which the cantilever is attached. You can always set this exposure and light so that you conveniently can see the cantilever in front of you. Now the first part before the experiment is started is to align the laser onto this cantilever. In the system, you have IR laser, which cannot be seen very nicely. But when this IR laser falls on very sharp edges, it will shine as a blue light. But where is the laser is a question now. So laser, when you start the experiment, laser will be where the crosswire is. So coming to the scan ahead again, we first switch on the laser, and then we will try to align the laser onto the cantilever as seen on the screen just previously, as I told you. To align the laser, there are two knobs. This is for the Y movement of the laser, and this is for the X movement. And these two are for the PSPD alignment. These two are for the cantilever movement, which we will not touch initially. This cantilever movement and the PSPD. First, initially, we will only turn the knobs for the Y and X movement of the laser itself. Now, as I told you, laser is at the crosswire. From the crosswire, we have to move up in the screen right now, so that it will go to the edge of the cantilever's attached position. How do you do that? Is turn this knob in clockwise direction so that the laser will move up from the crosswire now. I am going to move it in clockwise direction, and you will see the laser moving in the up direction, and as it comes to that edge, you can see that blue light over there. When it reaches there, so what I did was turn this in clockwise subtly so that the laser moved to that position. Then we will move this knob, X knob, so that it will move to the cantilever. So right now I will move it so that it will move to the cantilever. Right. As soon as it sits on the cantilever, we will see something happening on the PSPD. That is to say, the light is being reflected, or the laser is reflected from the cantilever onto the PSPD. Once it has moved to the cantilever, the job is not done yet. We have to move the laser to the cantilever's tip. So we come back again to the Y knob and move it in counterclockwise direction, like this. We will keep an eye on the intensity, and we will stop when it is giving something a reasonable intensity of reflection. Once we have that red spot in the PSPD, we need to align it into the center using these two knobs. This is for Y movement, this is for X movement. Moving that knob, you will see the spot on the PSPD moving. Job is to bring it to the center. As it comes to the center, you will see that it has become green. And whenever during the experiment, if it moves away and becomes red, you can always stop the experiment and move this PSPD knob so that it becomes green and comes to the center. Next step would be to get the crosswire or the cantilever to the crosswire using these two knobs. After this, we will go to the next step, that would be tuning the cantilever. So first initially go to setup, select the cantilever that you are using. Then go to this list of experiment and choose what is the experiment that you are going to do. So we will be doing NCM, and automatically as soon as you click on NCM, you will see this window where it will do the tuning and take the frequency, the dominant frequency, first frequency of tapping or non-contact. And the tuning is done. There is this amplitude which by default has been taken as 25.2, which can be varied according to the sample that you are scanning. So for smoother samples, you may keep this around 20, and as the roughness increases, you may increase the amplitude. So this is the amplitude of cantilever in air, and this set point what you see in front of you, that is a certain percentage lesser than this, and this is where the interaction of the tip to sample is expected. So later when we keep the sample and say approach, the tip will automatically move towards its surface, and when the amplitude of the cantilever reaches this particular value, the approach will stop. After the tuning, we will close this window, and because the line scan is running unnecessarily right now, we will switch off the line scan. Then we will now load the sample onto the stage. That will be here. So before we load the sample, move the stage out using this arrow keys. Once the stage is out, this is where the vacuum is. Small hole. We can load the sample here, and this is the vacuum switch. We can turn it on, and it's always a good habit to check whether the sample is moving by doing this. We will have to move this sample inside so that it comes under the tip. Then expand this for a better view. We have to go towards the sample. We have to take the Z stage towards the sample to a height about 3 mm to 5 mm over the sample using this. So as you can see, there are two buttons here. One is for Z stage movement, another is for focus stage, that is the optical focus. So Z stage, we will move down using this part and move up using this part. Towards the extreme ends of this will be the faster movement, and towards the middle will be slow movement. So we will press this so that the tip goes down towards the surface. And as you go closer and closer to the surface, you have to be careful. At this stage, make sure you look at the closeness of the tip towards the sample, and if it is like 3 to 5 mm, just stop. As you come closer to the surface, you will be able to see something in the background over here. Anyway, to focus on the sample, what we do is we use this focus stage, not this Z stage. Z stage, we have come to proximity of 3 to 5 mm above the surface, and after that we do not move it. Then we use this button, for focus state button, to move down below the cantilever. And as you come to the focus on the sample, you will be able to see it. Keep it in perfect focus, and then we go to the next step of scanning the surface. To scan the surface, so this is the focus of the sample. Next, to scan the surface, we have already tuned the cantilever over here, and we go to scan area here, and you can give what is the scan size that you want to give. You can give maximum up to 100 microns without any offset. With the offset, the size will decrease. Right now we will do some like 40 microns, and then if you want to change the folder, you come to the target directory over here and change it to whatever department you're coming from, your name and date, and select folder. You can change the file name over here. We will show you the software part in detail after this video. Anyway, so after giving 40 microns over here, we say approach. And before we do that, we will close the hood. And 14 microns of scan over the area of your interest. So let's come to an area over here. You can double click over to the place you want to go to, or you can navigate using these arrow marks. So let's go here, and then we say approach. On saying approach, it will automatically focus onto the cantilever position. And it will be pushed towards the surface, and as it reaches this value, it will stop. Now what we do is we switch on the line scan, and our job is to see this Z height and make sure that these yellow and blue lines are matched, or they that is trace and retrace, they overlap each other. Right now there is no interaction. So what we do is we come to set point, and also there is this advanced option, we will keep it checked in. We will be playing with these values. The set point, what we do is with the set point we reduce the value. So reduction of set point value would mean we are pushing the tip a little more closer towards the surface. Let us go stepwise. And after every change of set point or any other parameters, keep an eye on this Z height over here. If there is any change, you will be able to see it. So as you can see, at 15, there was this kind of interaction. As I come to 14, there is a certain big change. So right now, that tells me that there is an interaction between the tip and the sample. And for the timing, we'll just open only one channel. We don't need the NCM phase channel. Let's just look at this. And as you can see, this sample is a standard grid sample. So there are rows of squares, wells actually. So right now, as I'm expecting here, the tip is running between two rows, because you cannot see any wells over here. So what I will do is, you can always decrease this size of the scan area so that you are able to see this part better. Now my job is to match these two again by playing with these values. So as you can see, set point, when I reduce it further and further, this becomes better and better. There are other things to play with. first thing I will do is increase the minus Z gain. Again, coming back to set point, I'll reduce it further down. So that becomes further and further tight, right? You can also play with the I gain value. Just increase it and see whether it matches better. If it doesn't, go back to the previous one. So the software part is shown in a better way in another video. So you can follow that software part better for the training purpose.